Hi, this is Shannon from WTE. This is our TReX connected to our Web GUI interface. Here I will be demonstrating the basic menu structure and how to change configuration items. To start off with, press the menu button, the three-line icon here, and the top level of our menu is displayed. Here we have the basic system level items, so pressing the right button here takes us into one of the sub levels for the system, and here pressing the up and down arrows allows us to navigate through different items. Important in particular might be things like the RS-232 baud rate, so you'd just change one item, press the right arrow, select by pressing up and down to change the item, and then press the square button to accept that change. Also of particular interest in the system area is inside the factory level, which has the ability to set the TReX back to the original factory state through set defaults. That may be useful if the configuration is lost or unknown, or for some reason. I'm not going to do that here. Moving back to the menu top level, we have the RF aspects in the RF menu, and here we have all of the transmitter and receiver parameter items. Here we have the simplex mode. While the TReX is in the simplex mode, the receiver and transmitter have their modulation and frequency settings configured in this one place using these three items here. When it is configured to be duplex, then the receiver frequency and modulation is configured within the receiver level, which is down here. So a lot of menu items will have a long number. To change part of a long number, you move across to the digit that you wish to change, press the up and down arrows, and they can be changed, and pressing the square button will then commit those changes. Modulation refers to both the baud rate and the channel spacing that the transmitter and receiver uses. In this case, we're using 1200 baud at 25 kilohertz channel spacings. So pressing the up arrow, in this case, goes to 1200 baud 12.5 kilohertz channel spacing, and here 1200 baud at 6.25 kilohertz channel spacings. Moving on to the spectrum analyzer menu. Inside of here we have the frequency that the spectrum analyzer is centered at. The span can be configured by changing the hertz per division setting, and the sample defines whether the screen is continuously updated or continues to collect peak values. Moving into the spectrum analyzer screen, we can see this is the beginning of our span, the end frequency of our span, in which case here it's 460.1 megahertz, and moving down the screen we have the signal level. Moving to the top level again, we have the protocol menus. So these are the serial protocols that are handled for incoming and outgoing serial data. In this case, serial data going into the TReX is using our own WTE serial format that has been documented in our manual. Here we have the response that is sent out of the TReX when each message is transmitted, and moving into here we can see here that the message that is going to be sent out has a spelling mistake. It should be page sent. So we move across to the item that is incorrect. Pressing the up or down arrow allows that to be changed. It brings up another level of the text editor, and now we change it to pressing the back button here, goes to selects the G, and then pressing the square button accepts that change, and now the spelling mistake has been corrected. We have other key protocols that are configured, such as MQTT, that allows our IoT connectivity, details of our Modbus configuration, and other aspects. The top level again, we have the TCP configuration items, and here whether the unit is operating as a TCP server with a web server enabled. The web option must be enabled if the web user interface that we're using right now for this demonstration is to be used. All other aspects of the IP configuration are within this menu item. We have the telemetry top level screen, and this is used to enable our telemetry features such as our serial link that allows serial data to pass from the TReX, one TReX to another, and our point-to-point mirroring mode that simply reflects the inputs of one unit onto the outputs of another. Here we've got the here we have the top. We have our store forward main screen is our repeater operation. Inside of here, options of enabling the repeater and also how the duplicate reject feature operates. We have input configuration. In this case, for input 1, we see that it says H and that the I/O mirror mode has been used. We can change this by going into the input screen. We can see that for the low state of the input, it has zero transmissions configured. If we enable that to a single transmission for every change, and it can be any number of transmissions, then when we leave the menu again, we can see that it now displays that the high and low level processing for that input is active. Other aspects of the inputs, such as the battery monitoring and calibration, are handled here. For our outputs, we can configure for each output how it is going to operate. In this case, it is using our telemetry mode of operation, but it could be driven through any other mechanism. In this case, this output will operate when a message is received within a certain rec range, and here monoshot, when it receives a message to operate the output, it stays in that condition, but we can change that so that the output remains in the new state for just a shorter period of time. And that is the end of this very brief walkthrough of the menu system.